Hey guys, I know we've got a lot of kids out this today, so I wanted to do just a recap of the notes. This is unit 3.3. It's very short. It's just going to be this page, and then that's going to be it. It is solving rational and polynomial inequalities. So there are technically two separate homeworks. One is solving rational and one is polynomial. I think there's 6 and 8 questions a piece. They're very short. Really, they should have all been on one canvas. But we just wanted to keep the topics separate at the time, so when they were created. So there's total of 14 questions on the homework, 6 and 8 questions apiece. I'm going to work 5 examples total. There were only 4 on your notes. I changed examples 3's equation completely, so you will want to write that down. And then I added another example up here. It's something that you're going to see on the homework, but there weren't really any examples for on here for us. So I wanted to go ahead and just make an extra one for you. All right. So take a second, jot those down. I also changed example 4 from a 5x to a 6x because I want you to be able to we haven't done any of just factorable polynomials as well, and you'll see that on the homework. So I'm going to go ahead and get started. So you're going to combine all fractions on the left form one fraction to form one fraction, which is something we've been doing. So we're going to combine fractions, make sure that the right side equals 0, find the zeros of both the numerator and the denominator, plot these critical values on the number line, test x values in each interval to determine if the function is positive or negative, and determine the solution based on the information you have gathered. All right, so we're going to follow these steps. First off, on example 1, we have to combine all fractions on the left. So we're going to have to move this 3 over to the left side to make sure that the right side equals 0. So we have 3x plus 4 over x plus 2 minus 3 is greater than or equal to 0. All right, this is where we have to have everything with a common denominator in order to combine it. So the 3x plus 4 is going to stay the same over x plus 2. And then we're going to subtract it from, and we need the denominator to be x plus 2. So we are also going to put it in the top, x plus 2. All right, once we do that, we'll combine everything in the top. I'm going to go ahead and do that over here to the side. We have 3x plus 4 minus 3 times x plus 2. So we get 3x plus 4 minus 3x minus 6. So the 3x's cancel out, and we have a negative 2 is what we're left with in the denominator, or in the numerator, sorry. So we have negative 2 over x plus 2 is greater than or equal to 0. All right, this is our simplified version here. So the only point that we're going to need, because it says plot the critical values on the number line, that means find the zeros of both the numerator and the denominator. Because we have no x values left in the numerator, we have no zeros for the numerator. The only 0 we have is x plus 2. So if it's x plus 2, it is x equals negative 2. Technically, x cannot be negative 2 because it's in the denominator, but let's go ahead and make our number line, test these x values. We're going to put negative 2 on here. All right, and we're going to have an open circle on negative 2 because it is in the denominator, and that means it cannot be negative 2. All right, and then we're going to test values. It says test x values on each interval to determine if the function is positive or negative. So we're going to test an x value on this side and an x value on this side. So if this is a number line, we could do 0 here and negative 4. All right, so those are going to be the points that I test. So if I were to plug in 0 into the original inequality, does it prove to be greater than or equal to 3? We would end up with 4 over 2, which is 2. Is 2 greater than or equal to 3? No, it is not. So this side would not be used. If I'm to plug in negative 4, we would get negative 12 plus 4 over negative 2, which is going to be negative 8 over negative 2, which is equal to 4. And is 4 greater than or equal to 3? Yes. So this side is, this side of x values fits into the inequality. So if we were going to write this, it would be, we could write it as x values that are less than -2. We could also write it as x values from -infinity to -2. And it would be in parentheses, not bracket, because that -2 is not included. All right, we're going to do another example here. We have 1 over x is less than 1 over x plus 5. So we're going to move that to the other side here. I'm going to go ahead and like draw a line. So these are all over here. So we have 1 over x minus 1 over x plus 5 is less than 0. Common denominators here, we have to add x plus 5 to this left one. And then we have to add x to the right one. And that is less than 0. So we end up with x plus 5 minus x, which is just 5. So we end up with 5 over x times x plus 5, and this is less than 0. So this is our inequality. All right, we have no x values in the numerator, but we can plot the critical values from the denominator. So we have x is equal to 0, and then x is equal to -5. So these are the points that we will plot on our timeline, on our number line, sorry. So we have -5 and 0, and because they are both in the denominator, they are open circles, they are not included. All right, and then we would check. We could check 1, we can check -1, and we could check -6. We want to pick easy numbers that are going to be easy for us to plug into this inequality to see if they match. All right, so we have -6. So we would have 1 over -6 is less than 1 over -6 plus 5, which is -1. So this is -1 is greater than -1/6, which is false. -1/6 is technically greater, so it does not work here. When we plug in -1, we would get -1 is less than 1/4, which is true. And then if I were to plug in 1, I would have 1 is less than 1/6, which is false. So it would only be values. Our interval will be -5 to 0 here that we can use to make this inequality true. All right, and our final example up here, this one's going to be pretty easy overall. We don't have to move anything over. So we're to the point where combined all fractions from on the left. Make sure that the right side equals 0. Find the zeros of both the numerator and the denominator. So the 0 of the numerator is 3, and the 0 of the denominator is -1. So we're going to plot those points on our number line. We have -1 and +3. We'll plug in a 0, we'll plug in a 4, and a -2 to see which one is true. So if I plug in a 4, I would get 1 over 5 is less than or equal to 0, and that's false. If I plug in a 0, I get -3 over 1, which is less than or equal to 0, so that's true. So these values are included. And then if I plug in a -2, I get -5 over -1, which is 5, is less than or equal to 0, and that's false. So the only numbers we can use are from -1 to 3. Now let's talk for a minute about parentheses and brackets. So the -1 is in the denominator. That's open. The 3 is in the numerator. So we can use it. And if we use it, if I plug it in, I would get 3 minus 3, which is 0, over 4, which is less than or equal to 0 because it is 0. So we would include that 3. So our interval would be -1, 2, 3 with a bracket. Okay, on to the next one. For polynomial inequalities, find zeros, critical values, to put on a number line for interval analysis. Use test points. So this is where it's not a fraction anymore. We're just looking at polynomials down here. When looking at this one, we have to factor by grouping. It's already in a way that we can go ahead and group it. So we have 8x cubed plus 20x squared minus 18x minus 45. This is less than or equal to 0. I don't know why I wrote it back out, but let's say we just go ahead and group here. I would pull out a 4x squared, and then I would have a 2x plus 5. I could pull out a minus 9 and have a 2x plus 5 again. All right, so my factors would be 4x squared minus 9 and 2x plus 5. It's less than or equal to 0. So I would set each of these equal to 0, but for one, I can factor this one even further because we have an x squared. It's a difference of squares, but you have a square for each, the x and the 9. So difference of squares would be 2x minus 3 and 2x plus 3. And then we would also have 2x plus 5 again. So our points would be x is equal to 3 over 2, negative 3 over 2, and negative 5 over 2. So I'm going to plot these on the number line here. So we have negative 5 over 2, negative 3 over 2, and 3 over 2. So we could do 2, we could do 0. We could do negative 2, and we could do negative 3. All right, and I'll plug these all in to the equation, right? You can use a calculator for this portion. I'm also going to probably use this one down here. That's going to be a lot easier for me without a calculator. If I use 0, I would get negative 45 is less than or equal to 0, which is true. So I know that this area works. All right, if I use 2, we would get 1 times 7 times 9. We'd get 63 is less than or equal to 0, and that's false. If I use negative 2, I'd get negative 7, negative 1, 1. So I would end up with 7, which is less than or equal to 0. That's false. So this one doesn't work here. And then if I use negative 3, I would get negative 6 or negative 9, negative 3, and negative 1, which would give me a negative number. So it actually would work here. And because it's just a polynomial, we will include those values. So from negative infinity to negative 5 over 2, and then from negative 3 over 2 to 3 over 2, we are able to use those values as well, and that will be our interval there. All right, that one's a little bit more tricky. This one's going to be just a little bit easier because we're going to be able to factor it a little bit nicer. So when I move everything over, I end up with x squared plus 6x plus 8 is greater than or equal to 0. All right, for doing this, I'm going to have x plus 4, x plus 2. That means I'm going to be using negative 2 and negative 4 on my number line. All right, so I have negative 4, negative 2. I will use 0, negative 3, and negative 5, just to be always picking numbers just in between. So if I plug in 0, I would get 8 is greater than or equal to 0, so that's true. We will include negative 2. If I plug in negative 3, I would get 1 times negative 1, which would be negative 1. Greater than or equal to 0, false, so we cannot use this area. And then if I use negative 5, I would get negative 1 times negative 3, which is 3, and that is greater than 0. So I could use any value from negative infinity to negative 4 with a bracket. Oh, and I actually forgot that these are supposed to be brackets as well because they are included. The only parenthesis will be on the infinity. All right, and then from negative 2 to infinity. And that will be our interval. All right, and that is 3.3.